Hello students, in today's class we will start a new chapter, that is data structure. So in today's class we'll just have an introduction of data structure, and from next day onwards we will be studying in details each of these data structures. Now let us first know what is a data structure. A data structure is a way of storing and organizing data in a computer. Why we store and organize data in a particular way? So that it becomes easier for us to retrieve the data, to fetch the data when we are using it. So that's why we need a data structure. Now the data structures are generally based on the ability of a computer to fetch and store data at any place in its memory. And where is these data are stored? As we know that data are stored inside the memory of a computer, and these data can be retrieved or can be fetched with the help of the address, the place in which the data are stored. Now why we need to organize the data? Why? Because if we are organizing a data, then it becomes easier for us to retrieve or to get that data in a very less time. For example, if we consider the shelf of our book. Now, if we will keep our books in an organized manner, then what happens? When we search for a particular book, it becomes easier for us to get back that book from the shelf. Now, if we mixed up all our books and we keep them one book here, one book there, one book there, what will happen when we are going to search for a book? It becomes difficult for us to get that book. So, the same process applies here. If we keep the data in an organized manner, then it becomes easier for us to get that data. Okay? Now, there are two types of data structure. One we can say linear data structure, and the other one is non-linear data structure. Now, inside linear data structure, we will get array, stack, queue, and linked list. And inside non-linear data structure, we'll put graphs and trees. Though graphs are beyond the scope of your syllabus, we are having trees in our syllabus, so we'll read about trees. Okay, now let's come back to linear data structure. What is linear data structure? Why we are calling it linear data structure? A data structure is called linear if all its elements are arranged in a linear order. In linear data structure, the elements are stored in non-hierarchical way where each element has the successor and predecessors except the first and last element. Now here, for example, I have taken an array. Array is a linear data structure. Here the elements are arranged in a linear order. Okay, one after another. And what is happening? Each element has a successor. What we can say, this 11 is having a successor. This 9 is having a successor. The 17 is having a successor of 89. Yes. And predecessors. So if I say the predecessor of 1 is 89, the predecessor of 89 is 17, the predecessor of 17 is 9, except the first element and the last element. Only the first element is not having any predecessor, and the last element is not having any successor. Rest all the elements will have a predecessor and a successor. So this is known as a linear data structure. Next one is non-linear data structure. This data structure does not form a sequence, that is, each item or element is connected with two or more other items in a non-linear arrangement. That is, the data elements are not arranged in a sequential structure. Now, for example, I have taken this tree. Here you all can see that it gives a hierarchical structure and it is not linear. It is not in a sequential structure. Here what we can see, one element is connected with two or more elements. Okay, so this type of data structures are known as nonlinear data structure. Next is memory allocation. Now there are two types of memory allocations. One is static, another one is dynamic. Each of these data elements is stored in the physical memory of the computer called cells. The memory space can be allocated to these data items in two different ways. One is statically, one is dynamically. Now what is static memory allocation and what is dynamic memory allocation? A static memory allocation is a technique which reserves a fixed amount of memory before the actual processing takes place. Thus, the number of data elements to be stored must be predetermined. Now, for static memory allocations, again we will take the example of array. Now, when we are declaring an array, when we are creating an array, what we need to do? We need to predefine the size of the array. And we cannot change it during the execution, during the process. Like we cannot decrease the size of the array during the processing, or we cannot increase the size of the array during the processing. So here the amount of memory remains fixed. This is known as static memory allocation. Next is dynamic memory allocation. Dynamic memory allocation technique allocates memory during the actual execution of the program itself. This technique is superior to static and is preferred as it facilitates release of allocated memory space when not required. In dynamic memory allocation, what happens? During the execution or during the process, we can increase or decrease the size of the data structure on the amount of memory required, amount of memory space required for that data structure. We can increase it and we can decrease it. It does not has to be predefined. It does not has to be fixed. For example, linked list trees, these are allocated dynamically. Next is linked list. Now, what is a linked list? A linked list is a linear data structure where each element is a separate object. Each element as a node of a list consists of two items. One is data, another one is a linked part. Linked part means this contains the address of the next node, works as a reference. Now the node looks like this. You can see the structure here. It is having two parts. One is data part, another one is linked part. Now a linked list consists of this type of nodes. We are having a starting node that is known as the head of the linked list. It indicates the beginning of the list, and then we are having the nodes. You can see here the nodes are having a data part and the link part. The link part is connected to the next node. That means this link part is having the reference of the next node, or it contains the address of the next node to which it is pointing. And at the last node is having a reference of null. That means this is the end of the linked list. Next comes the stack. A stack is a linear data structure which enables the user to add and remove elements from the top end only, using the concept of LIFO, that is last in, first out. Now, as the insertion and deletions both are taken from one end, that is the top end, so what we need to do, we need to keep a record of that top end position. Now, there are two types of operations that we can perform in a stack. One is push, another one is pop. What is push? Push means inserting a data element into the stack, and pop means taking out or deleting the data element from the stack. Now, from which side we can push and from where we can pop? We can only insert and delete from the top end of the stack. As you can see in the diagram, it is shown here that this is the top of the stack, and from this top end we can insert and we can delete an element from the stack. Now, if we are inserting the first element in the stack, the first element will come from the top end side and will get inside the first location of the stack. This is the first location of the stack, so it will get stored in the first location. Now, if we are entering a second element, it will get inside the stack from the top end and it will come to the second location of the stack. In this way, the stack will get filled. Now, when we are deleting the element, when the stack gets filled, or when we try to delete an element from the stack, again we have to delete it from the top end. So, the element that has been entered at the last will be taken out first. Now, one more example you all can see, one more picture I have given. Here we can see that inside a jar, 3 balls are kept, one after another. Now, this is representing the LIFO concept of stack. What is happening? The ball which from which end we are putting inside the balls from the top end. Okay, one after another we have put the balls inside the jar. Now, which ball we will be taking out first? The one that is put at the last. This ball, the last ball will be taken out first because we are not having any other way of taking it out from the jar. There is no other option. There is no other opening from where we can take out the ball. Only one end is open. So, we will take out it from the top end. This is representing the concept of a stack. Next is queue. A queue is a linear data structure which enables the user to add from the rear end and remove elements from the front end only using the concept of FIFO, that is first in, first out. Now, insertion and deletion both takes place from different ends. We have to keep a record of the index of both the ends, that is front end and rear end. In case of stack, what was happening? Insertion and deletion was taken from one end only, from the top. In case of queue, insertion and deletion will be taken out from two ends. One is front end, another one is rear end. Now, the principal operations on the collections are NQ. NQ means addition of entities to the rear terminal. From the rear end we will insert, and DQ means removal of entities from the front end. Now, this is how a queue looks like. We are having a rear end and we are having a front end. Now, from the rear end we will add the items to the queue, and from the front end we will remove the items from the queue, that is first in, first out. The one who is coming first in the queue will be going out first from the queue. For example, we can consider this queue of, in front of the cinema hall we can consider, or we can consider the queue of line in a railway station to cut the tickets. What happens? The person who comes first takes the ticket and goes out first, and they maintain a queue in this similar way, one after another. The persons get on adding in the queue. Okay, so we can consider the last person is in the rear end and the first person is in the front end. So, first in, first out. This was all about queue. Now, two more important terms we need to know. One is underflow and one is overflow. What is underflow? If any of the above data structure is empty and we are trying to carry out delete operation. Suppose my stack is empty, but still I am trying to delete some elements from the stack. That time we will get underflow. And what is overflow? If my data structure is full, and again we are trying to insert some new elements in the data structure, that time we will get an error of overflow. Okay, so today's class we will do up to here only. This is just an introduction part to the data structure. From next class onwards, we will see in details the implementation of stack, queue and linked list one after another with the help of programs. So for today, I'll tell you all to go through this study material. You all get the basic concept of stack, queue and linked list clear. Then only you all can understand the programs from next class onwards. So for today, let us end our class here only. Thank you.